Exercise 9.1 Problem 2 Solution. Draw a circle of radius 4.8 cm. Take a point on the circle. Draw the tangent at that point using tangent chord theorem. Okay, so it's the same like the previous problem, but only thing is that they are asking us to specifically use the tangent chord theorem. Okay, so let's draw a rough figure. So basically we are having a circle with center O, and P is a point on the circle, right? That's what they say, take a point on the circle. And if you draw a chord from P, PQ is a chord, okay? And let's say this is your tangent, okay? That is T dash P T dash TPT, right? T dash PT is your chord. So this is the and then you draw one more chord on the largest segment, okay, on the alternate segment. So this is one chord, and this is a smaller segment of the circle, and the alternate segment is P, okay, this part of it. So mark one more point on it, R, which is distinctly different from Q, okay, and it has to be in the anti-clockwise direction. Okay, so now let's mark R. So this is PRQ. Now what tangent chord theorem says, and connect PR and QR. What tangent chord theorem says is that this angle is equal to this angle. That is the angle between the chord and the tangent which is drawn at the one end of the chord. This is, say, the QP is your PQ is your chord, and the tangent drawn at one end of it, that is P. Okay, the angle between the chord and the tangent drawn at one end of the chord is equal to the angle subtended by the chord on the alternate segment of the circle. So the angle subtended by the same chord on the alternate segment. This is the alternate segment, right? So this is one segment. This is a segment of the chord, and the alternate segment is this, and the angle subtended by this chord in the alternate segment, which is PRQ, is equal to this angle. That is what the tangent chord theorem says. So we'll have to use that principle to draw the tangent. Okay, now let's start it. So fair diagram with O as a center, draw a circle, and the radius of the circle is 4.8 cm, which is given in the problem. So let's take a point P on that. All right, now we'll have to draw a chord, and let's name that PQ. So this is our chord. Okay, from here draw a chord. Next, what should we do? We'll have to take a point R, which is away, a little away from Q, and it has to be in the counterclockwise direction. See, now you see PQR is, that is, you should not take a point in this segment. Okay, so you should be taking it away out of this segment in the alternate segment. This is the alternate segment. This is the segment of the chord. Okay, so this is the alternate segment. You have to take a point R in the alternate segment, and it has to be in the counterclockwise direction. That's what they say, counterclockwise direction. Now you see QRP is in the counterclockwise direction. Now you join QR and PQ. Now as per the tangent chord theorem, this angle and the angle between this chord and the tangent are the same. So what we should do? Now we'll have to find this angle and draw the same angle here at P. That is QP. Let's see if T is the tangent. So QPT must be the same as PRQ. So you'll have to draw the same angle. How will you draw this angle? From R, you'll have to draw an arc. Draw an arc. Then you measure, now you have the radius, let's say the radius is x centimeter. So from P, with the same x centimeter radius, draw an arc. Okay, so we are drawing an arc, okay, cutting these two lines, that is PR and RQ, okay, with a radius of x centimeter. With the same radius, but with P as a center, draw an arc. Now you measure this distance, the length or the chord length of this arc, and with the same length and with this point as a center, draw one more arc cutting the first arc. So let's say it's intersecting at this point. Join P and this point of intersection and extend it, and that is your tangent. So T dash PT is your tangent. Now let me repeat. So basically what is our tangent chord theorem? QP and the angle between the QP, the chord, and the tangent TPT, or PT is a tangent, okay, is equal to, is the same as the angle which is in the subtended by the chord in the alternate segment, that is QPT equal to PRQ. So we know PRQ because what did we do? We selected the point R and we connected them, so which means we know the angle. So with the same angle, you have to draw a line from P. So how did you do? From R, you took a radius, let's say radius of x centimeter, and you drew a arc which is intersecting, cutting these two lines PR and QR. Then with the same radius from P, you're drawing an arc cutting PQ. Then you're measuring this length of this segment, okay, with the same length, with the same radius, but with this as a center, you're drawing one more arc cutting the first arc. So that point of intersection, if you connect with P, you will get an angle QPT which is equal to this angle, that is PRQ. Okay, so that is how this problem needs to be done. So let's go through the construction. So with O as a center, you're drawing a circle of 4.8 centimeter. Next, with P, you're taking a point P on this circle. Then through P, draw any chord. So you're drawing a chord PQ. Then mark a point. So mark a point R distinct from P and Q on the circle so that PQR are in the counterclockwise direction. So we'll have to mark a point R on the circle. Okay. So but the key is you should not mark it between P and Q in this smaller segment. You have to mark it in the alternate segment. That is why they're saying you have to mark it in such a way, okay, such a way PQR is in the counterclock. If you mark it here, what will happen? It will be in the clock. It should be away, okay, distinct from P and Q, okay, and PQR are in the counterclockwise direction, okay. Right, so PQR, so mark it here so that now it is in the counterclockwise direction. PQR is in the counterclockwise direction, right? So it should not be PRQ, it should be PQR. If you mark it here, it will become PRQ, right? It should be PQR, so you are marking it here. Now join PR and PQ. Next, now all we need as per tangent chord theorem, this angle is equal to this angle, right? So what we need to know as per tangent chord theorem, you know, this angle is equal to this angle. So all we need to do is we have to draw a line PT which is having an angle, that is QPT must be equal to QRP. That's all we need to do. But that is how we did. How did we? But though it's not explained here, we know how we did. We from point R, with R as the center and x centimeters, maybe 1 centimeter or 2 centimeter, whatever suits you. That's what I'm saying, x centimeter. Draw an arc which is cutting these two lines. With the same radius from P as a center, draw another arc. Okay, then you measure the length of this arc. That is the measure of the chord. So measure the length of this chord. Okay, with that as a radius, and keep that as a radius. With that as a radius, and this point as a center, draw another arc, cutting the first arc. So that will cut at one point and join P and that point of intersection and extend it. That becomes a tangent. So this is how we draw the angle QPT, which is equal to PRQ. You are drawing an arc, and with the same radius, you're drawing an arc from P. Okay, you're measuring the segment length, and you're drawing with the same radius from here. You're cutting one more arc. That is how you'll be able to get the same angle, right? Now that's fine. So at P, what are we supposed? We are supposed to draw QPT, which is equal to PRQ. QPT, that is what we just did. QPT will be equal to PRQ, and extend PT, that becomes the tangent. Okay, so I hope it's clear. If not, please go through one more time. It will become clear. Thanks for watching this video.